Alright, we are now still in 10.1, but we're ready for example 4. We're taking the limits of these sequences now. Your definitions are in your text. Write the first 4 terms of each sequence. If you believe the sequence converges, make a conjecture about its limit. If the sequence appears to diverge, explain why. Okay, so part A. Ooh, that was a really sad brace. Okay. -1 to the n over n squared plus 1, and we're doing the sequence from n is 1 to infinity. It is an explicit formula. So if we start listing terms, if I stick in 1, I get a -1 over 2. If I stick in a 2, I get a +1 over 5. If I stick in a 3, I get a -1 over 10. And it wants the first 4 terms. If I stick in a 4, I get a +1 over 17. So those are my terms, ... And if I look at those, they are alternating, but they are getting tinier and tinier and tinier. And if I graphed them, I could see that they were approaching something. So I'm going to say the terms decrease in magnitude and they approach 0 with alternating signs, so the limit appears to be 0. Alright, and you can do that by graphing it and looking at it. Part B, another explicit one. Cosine of n pi. N equals 1 to infinity. Okay, so if I start listing out terms of this, if I stick in 1, the cosine of 1 pi, the cosine of pi is -1. Then I'm doing the cosine of 2 pi. Okay, that's 1. Cosine of 3 pi is -1. Cosine of 4 pi is 1. Oops, ... Okay, this one's alternating back and forth between 1 and -1. It's not approaching a single variable, so I'm going to say the series diverges. Part C, this is a recursive one. They said to us that a sub 1 is 1. They always put the first term last. I don't like that. Oops. A sub n plus 1 is equal to -2 a to the n, a sub n. So, first term is 1. Then I stick the 1 in and I get -2. Then I stick the -2 in and I get 4. Then I stick the the 4 in and I get -8, ... Okay, it's alternating, but the terms are getting larger. They're increasing without bound because they keep doubling. So these dots would be alternating back and forth across the x-axis, but getting further and further away from the x-axis. So I say this one also diverges. And that's the end of example 4. So let's look at example 5. Enumerate and graph the terms of the following sequence and make a conjecture about its limit. So it's 4n cubed over n cubed plus 1. And see now for n is equal to 1, 2, 3, ... That's an explicit formula. I would go to my calculator. I would store this in my y1 and put in the graphing part. y1 is equal to 4x cubed over x cubed plus 1. Then go back, like I was showing you in a previous pencast, and go and get the var button, which is near the arrows on the calculator. Pick y. Oh, that's going to take too long. I don't want to do that. I've already set my table up, but in case you have forgotten how you do that, you would go to... Make sure you set this up. If you've already done it, you don't have to do this part. But you would go to Second Window, move to the Independent part, and it's abbreviated IND, PNT, and make sure that ask is the one that has the black box on it. Then I would go to second graph, which would be the table part of the calculator, and I could start entering in my numbers because I've set it up where it's going to allow me to enter in numbers. So I would put in 1, and my calculator will say, and I'm just going to give you the list that I get. Hang on a second here. Okay, I've plugged them all in my calculator, and I've written down these numbers, and you could do more than 8 if you needed to, but 8 is more than enough. When I graphed them, you'll notice that they are getting higher and higher and higher, and it appears that they are coming out to a top-out value. They will never go past 4. So it says, I'll make a conjecture. So I'm going to say that it has a limit, and the limit is 4. And that concludes example 5. So now we're going to go on to example 6. Okay, we got a bouncing ball. This is a classic problem. A basketball tossed straight up into the air reaches a high point and falls to the floor. Each time the ball bounces on the floor, it rebounds to 0.8 of its previous height. Let h sub n be the height point after the nth bounce, and the initial height being h sub 0 equals 20. Okay, so they're throwing it up, and it's going down, and we're going to stretch it out like it moved because we're going to do the graph over time. And then it goes an eighth of the way, and then it goes an eighth of a way, and eight tenths of a way, and it keeps going like this, where this is your time. That's a time graph, and the y-axis would be your height. Okay, so now we're starting out with h sub 0 is 20 feet. H sub 1 would then be 0.8 of 20 feet, which is 16 feet. H sub 2 would be 0.8 of 16 feet, which is the same as writing 0.8 squared times 20 feet, and that would be 12.8 feet. If I go to h sub 3, I would take my 20 feet and times it by 0.83 times and get 10.24 feet. So part A says, find a recurrence relation and an explicit formula for the sequence. Okay, so recursively. And they are starting at 0, and it makes sense because h sub 0 they told us was 20. So we'll start out with h sub 0 equal to 20, and so h sub n is going to be h sub n plus 1 is going to be 0.8 times h sub n, for n equals 0, 1, 2, 3, and so on. Have to start this one at 0. The explicit formula, well, I basically wrote it right there when I was setting those up. This is my recursive. Here is my explicit. I need one formula that generates it. Well, we start out with 20, and then we have to times it by 0.8. Now the question is, what's the exponent on this? Well, I start out with 20, and the first time I don't times it by 0.8, so I would have to start at 0. Then when I'm on h sub 1, I times it by 0.8 once. So first h sub 1 one time, h sub 2 I did it 2 times. So this is just an n, but then I have to specify n starts at 0, 1, 2, and so on in order for that one to work. Part B. Part B wants to know, what is the high point after the 10th bounce and after the 20th bounce? Okay, 10th bounce, 20th bounce. It's going to be easy if we use the explicit formula. So I'm looking for the 10th bounce. Well, h sub 0 was before I threw it up in the air. So h sub 1 would be the first bounce. So if I want the 10th bounce, I'm trying to find h sub 10. So I plug it into my formula, and I get 2.15 feet. And then h sub 20, same deal, 0.8 to the 20th, and we get 0.23 feet. And these are approximate answers. I've got to round them. Then part C, speculate on the limit of the sequence. So they're asking us to decide in part C, as n gets large, so n is going to go out to infinity, as n approaches infinity, what is this sequence approaching? Well, if you look at the places where the ball is hitting each time, it's getting lower and lower and lower. It is heading towards 0. So the limit, in this case, is 0. Because they keep decreasing in size and they're heading towards 0. And that is the end of number 6.